All right, time to get into Chapter 3, System Software. Now, when it comes to your system software, all this is software that is meant to control the computer's hardware and its peripheral devices. One of those things is going to be the opposite operating systems, which job is to manage the system resources and provide an interface for you to communicate with the hardware and other software. This is usually going to be stored on your hard drive. It technically could run off a flash drive or a portable hard drive or something, but you really want to use a nice fast SSD for this to make your computer feel a bit snappier. We'll come back to operating systems in a little bit. Next, you're going to have some system utilities. These are going to be things that are part of the OS install. One of those things would be your task manager, which you can see here. So you got a task manager there showing everything that's running on my background. You could do Windows Defender, you got your firewall, file explorer, all those wonderful things. There's a lot of utilities going on in the background that help keep your computer running. You also have utility software, and this is going to help you enable you to maintain, repair, and protect your computer. This could be included with the OS or purchased from another company, or it could be something that you've added on yourself. A great example of that would be McAfee virus software. So there's a lot of options out there for those types of things. Now up on the screen, I've got some system resources that are going to be on your computer. We talked about your processor in chapter 2, I believe, but just a quick reminder, your processor is what allows your computer to run. It's what's got the processing. It actually is what is doing all this, the programs and things like that. So for the system resources, this is going to help the OS manage the instructions sent to the processor and allocate memory for the tasks that is needed. So as your memory as well. Now your computer is really multitasking. So when you are sending, trying to have all these programs open, it's not actually processing everything at once. Nowadays with our multi-CPU computers, we're getting better at that, but it's still not something that your computer is truly multitasking. I mean, besides those 4 CPUs or those whatever how many CPUs you have, of course. However, most of the time we're doing multitasking. So it's actually sending a few lines of code from one program and a few lines from the next, and a few lines to the next. It's trying to keep track of everything it's doing, but it's still only really able to process one line of code at a time. It's not true multitasking. But then again, most people can't really multitask anyway. We all think we can. We watch YouTube videos while we're trying to do our homework, and your homework takes you 10 times longer to do than if you would have just sat down and done it. So, a little bit of give and take going there. We also, with the multitasking, the processor and the computer are assigning each program on your computer is assigned to a memory area that keeps it from interfering with the process of other programs. And that's going to be like the buffer in your RAM. So the buffer is using the RAM to temporarily hold data or instructions. So again, that multitasking, it's like, all right, I'm done with you. Let me go put that in the buffer. Let me wait. And then once I'm ready, I'm going to go back to the RAM, grab you, and continue on with that process, which is why we need extremely fast RAM. In the chapter 2, I believe it was, we talked about how many gigs of RAM you need and said like 11 was a good number. So I suggest at least 8, if not 16 gigabytes of RAM. Now, what happens when your computer runs out of RAM? It doesn't just die, it keeps going. All right. So we get to virtual memory. And virtual memory is using your hard drive as an extension of RAM. So if you were trying to run something that used 11 gigs of RAM and you only had 8 available, it's going to put 3 gigs of information onto your hard drive temporarily. Now that is going to be slower, so that is the downside here. You want really fast memory. Having an old traditional spinning disk hard drive is not going to be your best way for virtual memory. Even SSDs are nowhere near as fast as your RAM is. So you really want to have as much RAM as possible in your computer to help keep it running at a good rate. Now, part of that virtual RAM is swap file or paging files. And this is how the virtual memory actually stores information. So it's putting it into a paging file. And that's where the term paging comes from. So it's the process of moving information from RAM to your virtual memory. As we continue along, this was multitasking, and then this is your virtual memory. So you can see how on the left-hand side we've got our page files that gets moved to our memory map, and we got arrows taking it different places. So just kind of something to be aware of. Now, when it comes to functions of your computer, the first one is post, which is your power on self-test. That's the first thing your motherboard is going to do. And this is testing all the hardware to make sure that it's working correctly. If you have a higher end motherboard, you may actually have a little display on your motherboard that's giving you postcodes. So that way, if something isn't working correctly, you can say, okay, that's code number 36. You look up 36 on the motherboard website and it says it's a graphics card error or memory error or a hard drive error or whatever the problem is. Many computers do not have those. Most of them do have some sort of LED light that will blink that will allow you to help hopefully decode what is going on though. So it will help you determine what the problem is. So that is definitely something that you want to be thinking about. Next, we have plug and play, PNP. This is how we can easily add new hardware to a computer by automatically setting up the computer, so we don't have to think about it. Would you imagine if every time you plugged a flash drive or a mouse or keyboard or printer or something and you had to go through some crazy setup process? We don't for most things, and that's because of plug and play. It's a way that we can just plug a thing in and Windows does all the rest of the hard work for you in the background. It may take a minute or two to set up. Most things don't take that long, but some of them could take that long. And the plug and play is doing something with drivers. So it's actually, a driver is, I should say, is a translator that enables the computer and device to communicate. So the driver is telling the computer every time you see this, it actually means left click, and every time you see that, it means right click. And that driver is a very important file. They will have upgraded versions of those, so you want to do want to keep your drivers updated. Now, if the driver is not available on the computer, Windows will look for it on the internet for you, and hopefully it's going to find it. It often will not, well, maybe not often, but sometimes it will not. Or sometimes you may want to go back to an old driver or something for some odd reason. The new one's not working properly, whatever the case is. So sometimes you'll have to go out and find it yourself. If you're lucky, the manufacturer sent a disk to accompany your new device that has that driver on it. However, nowadays, we don't really get CDs with anything anymore, so you have to go out to the internet, onto the website to find that. Sometimes it's got software that goes along with it. If you have a gaming mouse and programmable buttons, you'll be able to set that up using that software. So a little bit of give and take going on there. Drivers are wonderful, but they can be a royal pain when they're not working. Next, we have our firmware for our device, and this is software that's stored on the flash ROM chip. If you do not remember, ROM is read-only memory. All right. And this read-only memory is built into the device to provide instructions on how the device communicates with other hardware. And this, could be firmware on your phone, on your digital camera, on your smartwatch, whatever the case is. Nowadays, we have what's called EEPROM, which is electronically erasable programmable read-only memory. It used to be you would write a ROM chip once, and that was all. And when you wanted to upgrade your firmware, you would actually buy a new chip, and you'd write a new chip, and then you'd take the old chip out and put the new chip in. Nowadays, we can erase it electronically, which is very, very useful. The BIOS that you might have on your computer is the basic input-output system, and this is in the form of firmware for your motherboard, basically. So the post and BIOS are kind of working together. Next, we have our API, which is our Application Programming Interface. This provides for communication between the OS and the software, enabling the allocation of resources needed to run the application. Some common APIs that you might use on your computer without even realizing it are file serving or printing requests. So if you think about it, if everyone had to write their own software to print something, that would be ridiculous. So instead, we have all of the printing tasks that Windows offers up an API for, and it says, hey, if you want to print, here's how we do it. Here's the request information that you can send me, and I'll know what to do with it. So Windows tried to take care of that for you. And lastly, on this page, we've got green computing, which is just putting your computer in low power mode that helps save on home cooling costs and prolong the life of your notebook battery and everything else. So it's nice to be able to your computer instant on, but it's not the best thing in the world. Now, when it comes to your operating system, we've got a few things we need to think about as our interface, so how you're going to interact with it, our categories, are they embedded or are they mobile? All right, the user face and categories we'll talk about in a minute. I want to talk about embedded here. Well, I guess, yeah, embedded. Go back up slide. There we go. So embedded OSs are all around us. So if you have a GPS for your car, that's not your phone, that will have an embedded OS. If you have a digital camera, that has an embedded OS. Any of these electronic devices, video games, ATMs, they all are embedded operating systems. And this is just specialized software that's meant to manage the resources of a specific device for which they were written. So these embedded OSs only work on those devices. They're not designed to be a very universal device like Windows is, where you can install it on many different motherboards with many different CPUs. Embedded devices are meant for one specific CPU and with one specific motherboard, maybe 2 or 3 motherboards, but overall it's meant for a very limited set. Now, when it comes to our user interface, it used to be command driven, which is what you see on the screen. You used to be typing out your commands. In this case, we are typing out ping. So we're actually sending a request to fa.wikipedia.org. Sorry for the horrible drawing. But you'd actually have to know what all the commands were, all the syntax, and how you're going to type things and all those other wonderful things. This is not a very intuitive interface, which makes it very hard for someone new to learn it or for someone to jump into a system that they're not familiar with. However, it is very easy to automate. So if you wanted to do this, you could set up a cron job, which is meant for scheduling, and you could just be like, okay, every day at 3 a.m. ping this, or every 5 minutes ping this, or whatever the case is, to make sure that you still have good internet connection. This is still used very extensively today, mainly for servers, but it is definitely still used today. For Windows, we call it command line, or the newer version is now PowerShell, which has its own syntax available. So far, I'm not a big fan of PowerShell, but I also don't use it consistently. I'm used to command line. So maybe once I get used to PowerShell, it'll become my new friend. Said with anything that's terminal or command driven, you need to know everything. What syntax? How do I organize it? What the -q means? Those types of things. So it becomes kind of complicated. Next, we have a menu-driven system, which is what I see on the screen. Sorry for the fuzziness. But anyway, menu-driven is a bit nicer. It's an interface you choose commands from menu displayed on the screen. This eliminates the need for users to know every command. So you'd be like, I want to zoom in. And it's like, okay, is it under view or tools? And it's like, oh, it's under zoom or tool. It's under view, zoom would be. So you could come down here, click it, and then you get some more menus. And you'd be able to click things. This could be using a mouse, or this could be purely with a keyboard. You'd press a specific key to bring up your menu subsystem. So it's better than a command one because you don't have to remember all the specifics, but it's still not a great system in the long run. Now that takes us to where we are today with GUIs, or graphical user interfaces. This is what we're using basically on most devices. This allows us to do point and click technology with a mouse and keyboard. Now, the one thing I will say is GUIs are wonderful. They look pretty. They're great for people to learn. They are not the quickest. All right. If you have keyboard shortcuts, you're going to save yourself so much time. Imagine if instead of using Control-C to copy, if every time you had to use, write something, highlight it with the mouse, right-click, say copy, and then you had to go somewhere, right-click, and paste. It's so much easier just to use Control-C on the keyboard, use the arrow keys to move around, and Control-Paste. So if you have the opportunity to use keyboard shortcuts, I highly suggest it. It'll make you more efficient when using a computer. It'll make it more streamlined, and it'll make it more enjoyable because you're not having to use the mouse and move your hands as much. Now, the user interface and all the different operating systems are getting close, but they're not perfect. So Windows right now, we're at Windows 11 actually. I have Windows 10 up on the screen, but that is where we are. That's developed by Microsoft. We have Mac OS, developed by Apple. And then you also have Linux. So those are all the ones that are for PCs, personal computers, Windows, Mac, and Linux. When you move into the mobile world of tablets and phones, your main ones are iOS and Android. Technically, there are some tablets that are Windows, like the Microsoft Surface is a tablet, and there also are some smartphones that are run by Windows. Not very many. So Android and iOS are our main mobile ones. Try to throw little M's on top of these in a horrible fashion. All right, and then you have the last one, which is Chromebooks, and this is Chrome OS, written by Google. It is designed to be a lightweight operating system and to run on hardware that's not very expensive. That's at least that it was originally designed for. Many schools have started using Chrome OS. So it's cheaper. Google has some good discounts on them. It's all web-based, so everything has to be software as a service, or SaaS. So it's got its place. It's great for kids, but maybe as a productivity device, it may not be the best option for you. I do have some numbers in here from when I made this PowerPoint a few years ago, but Windows is, maybe it's on the next slide. Here we go. Windows for personal computers is around 79.24% of personal computers. Mac is on 14%. Chrome is about 1.5%, and Linux is about 2%. And if you look up here, most of what we see up here is blue. This is the mobile market. So Android is running, no, Android is blue, Android is green, Windows is blue, iOS is red. So these are mobile devices. So you can see that most of the world is rocking Android. There is a little bit of red for iOS. I guess this is the main operating system market share. So there's a little bit of red rocking around, but for the most part, we're looking at blue for Windows, where Windows is the end all. Android for the main operating, though, depending on where you are, has definitely taken off. So that's just kind of interesting to look at. Now, the one operating system that many of you might have heard of but have never touched is Linux. This is an open source operating system. And Tux the Penguin, as you see on the screen, is kind of the mascot for it. The story goes that the the person who originally wrote Linux was attacked by a penguin, so he decided to name his operating system after it. Um, Anyway, so it is mainly open source. It is designed for personal computers, and web servers. So servers is where Linux really is the like king. I believe in like the top 100 sites or something like that, or server farms or whatever I'm going to go with, like 90 some percent of those servers are running Linux. So it is a huge market share when it comes to service. For average PC use, it is basically non-existent, but for servers, it is huge. You have updates versus upgrades. So you have to update the newest features of the OS depending on what you're using. And there are different distributions and platform, and it's a never-ending game here, is really what it comes down to. But the one thing I want to point out for personal use is the main decision factor when you're buying a computer should be, does the OS matter? And the question is, does the software you want to use work? So does the operating system matter? Does it matter if everything you're doing is in a web browser? You could use Linux, you could use Android, you could use iOS. It doesn't matter. As long as it can run in a web browser, basically every smart device nowadays has a web browser built into it. Or I should say computer, smartphone, those things. Now, if you need to run something that only has Windows program, then operating system is going to matter more. Yes, you can dual boot your Mac or run it in parallels, but it's not as clean of a user experience as just running Windows. So something that you really want to take into mind or account when you're doing these types of things and when you're looking at buying a new computer is, what am I going to use this for? Now, there is another type of operating system called an RTOS, or a real-time operating system. These are specifically designed for networks, machinery, businesses, those types of things. If a machine that performs repetitive series of specific tasks in an exact amount of time requires a real-time operating system. Some examples of this would be a POS, a point of sale system, car engines, robotics, anything that requires high precision, because Windows with its multitasking is like, I'm going to do this, and then it's like, I'm going to do that. It just kind of does things at its own rate, where doing it on a on a real-time operating, it's like, oh, I need to listen for this, otherwise I'm going to miss the filling mark and the recipe is going to be off, or whatever the case is. So the other one is that multi-user operating system. These are traditionally going to be some sort of like network OS, so a network operating system, and so it's a software that allows multiple computers to communicate, share files with hardware devices with one another, which is nice because it provides a centralized resource storage and security, those types of things. You do have your clients and your servers. So clients are what access the servers. So a little bit of going on there. You have your P2P or peer-to-peer, so which is where each computer is considered an equal. This is what most of us have at our houses. We don't have one computer that's a server that everyone else is trying to access. All the devices are overall equivalent to each other. So no matter what you're doing, they're all just like, yep, I'm doing my own thing. I might try to access like a network printer or something like that, but for the most part, everybody is running peer-to-peer. Now, virtual desktop interface, which I don't have on here, or VDIs, are personal computers that all of their resources are located on a server. So you may sit down at a computer, you may log in, you may think you're logging into an actual computer, but in reality, you're actually logging into a server somewhere else where all of the processor and RAM and storage and everything is located. The nice thing about this is your computers that you're sitting in front of are easily upgradable. You can change one image and change every computer on that network the next time they log in. So there are some really big benefits to virtual desktop interfaces. The downside is they are typically a little bit slower because they rely so heavily on network resources. So if you don't have a good networking system set up, it's going to be on the slower side. Some file types. And the whole reason that we have file types on our computer is to inform your computer what program to open with. So, a docx file, a Microsoft Word file, the whole point it's there is so that way when you double click on it, Windows goes, oh, docx, that's associated with Microsoft Word, or PDF, right now that's associated with Adobe Reader, whatever the case is. That's the whole point we have file types. Other than that, all they are is a bunch of zeros and ones. And by giving it a file type, we're telling it this program knows how to open this and read this file. Nothing else special is going on there. There are two different types of file types, though. You have program and device drivers, so those are ones for the function of the computer, and then you have the ones that you create, so the DOCXs. When it comes to your file name, you should have two parts: the actual name of the file and that file extension. Depending on your OS you're using, the file name only can be so long and only can use certain symbols and characters and things like that. If you want to be really friendly to anybody using your files, you really want to avoid using spaces. I know it makes it easier for you to read the file, but for the benefit of other people using your computer, your files, no matter if they're on Linux or Mac or Windows, avoid spaces because it'll make everyone's life a little bit easier. Use underscores or capitalize every first letter, something along those lines, to help differentiate where things are. On the right-hand side of this screen, I have different hard drive formats. All right, so depending on what you're doing and what type of system you're on, you're going to have a different hard drive format. And for the most part, this will never affect you unless you're trying to move data from one computer to another, then it could matter. Or file size. So if you have a 4 gig file, it will not fit on a FAT16 file type. You need to be on a FAT32 or an NTFS or maybe an APFS. So that's the real reason I like to point this out. HFS is, I believe, the go-to for Apple. Oh no, it's being phased out. HFS Plus is what the new Apple one is. So the first one is being phased out. And then the Apple file system, APFS, was released in 2017. It's going to be replacing the HFS Plus. So you got to be kind of careful about that. It used to be if you had a Mac hard drive and you plugged into a Windows computer, you wouldn't be able to read anything. Windows to Mac, you'd be okay, but Mac to Windows, you couldn't actually read it because Windows did not know how to deal with that hard drive formatting system. Nowadays, there are programs out there that can allow you to read them, so it's much nicer. This is also why network file share is my suggestion for you. So anyway, but those are some different hard drive formats that you might see at some point in your life. When it comes to Windows File Explorer, we've already done a lab on this, so I'm just going to keep moving. Now, cloud storage is absolutely wonderful and terrifying at the same time. So cloud storage is you storing your files on a computer that is located out on the internet. Traditionally, this is going to be someone else's computer. So everything I have up there, iCloud, OneDrive, Google Drive, Dropbox, those are all somebody else's computer that you don't actually know. It's some company who you're either using their service for free or you are paying for it. And the question is always, do you trust them? Very recently, one of the big password managers was hacked. So it's like, well, if you stored all your passwords to that password manager, how much do you trust those now? Now, luckily, they did say that none of the user data was, the passwords were accessed, maybe some addresses or customer information about you, but not your actual passwords. They also said that because of how they encrypt everyone's passwords with only you having the master key, they don't know what your password is, so all of the data is encrypted anyway. So it doesn't matter really if someone were to get a hold of that, because everyone would have their own encryption key that they would then have to go hack through to figure out all the access to people's passwords. So it's not as simple of a system as you would think just to manage your passwords. But anyway, cloud storage is great though. Otherwise, it allows easily sharing files from one person to another. I did a demo in class that showed how we could have 20 people accessing the exact same Excel file at one time, which to me is just ridiculous. I wish I had that back in high school when I was in college, when I was doing group projects, and we were like emailing files to each other. It was a mess. Nowadays, you just share a link and everybody can come on and edit it. You can all be there at once talking, and you can see where people are working and things like that. So it's a much nicer system nowadays. You normally are accessing this over the web. So you can do it in the web browser. Some of them have specific apps, a little bit of give and take going on there. Otherwise, that is a quick review of Chapter 3. I hope you enjoyed it.